Welcome to this week's Short Clip Friday podcast. On Fridays, I will be posting clips from previous episodes, and the point here is just to bring you some of the highest yield topics from each podcast in order to kind of reinforce those topics. This clip is from the Kinetics podcast and covers reaction rate order. Enjoy. So in general, a rate law describes the rate of reaction in terms of different variables that you know. So it can be a lot of different variables. You can have these really complex rate laws that involve fractions and weird exponents and stuff, but you're really only going to see pretty simple stuff on the MCAT. So that's what I'm going to talk about. And typically what you'll see is something along the lines of the rate of reaction, which is also called the reaction velocity, is equal to a constant times the concentration of reactant 1 raised to some power times the concentration of reactant 2 raised to some power times the concentration of reactant 3 raised to some power, and so on. So just to give a quick example, imagine that we have this reaction in which A plus B go on to make C and D. Well, then the rate law would be that the reaction rate is equal to K times the concentration of A raised to some power times the concentration of B raised to some power. And these powers are really what you're going to be interested in finding because this determines the reaction's order. So again, you have A to some power, and that is the reaction order with respect to reactant A. And then you have B to some power, and that power is the reaction's order with respect to reactant B. And together, if I was to add up those two exponents, that would be the total reaction order. And a lot of the questions that you're going to see about rate laws on the MCAT are going to kind of revolve around finding the reaction order. And so there's two different ways of determining the order of a reaction. And the first of which is using experimental data, which you might remember from Gen Chem. And the second is knowing that the reaction is an elementary reaction and then using the reaction stoichiometry to then fill in the exponents. And those can be kind of mixed up sometimes, and I'll get into what I mean by that. But first, let me talk about how we can determine the rate laws using experimental data. So the experimental data that you'll be given is just going to be a series of experiments in which someone added varying amounts of reactants and then measured the initial reaction rate of some reaction. And I don't know if I mentioned this already, but the units of reaction rate are usually in moles per second or nanomoles per second, some kind of molar concentration divided by seconds. So it's good to know. As I was saying, you'll be given experimental data. This data will be in the form of changing reactants and then looking at reaction rates. And so what you'll be looking for is you'll be looking for two experiments in which only one of the reactants is changing. In other words, you're holding constant all the reactants except for one, and then that lets you kind of determine the effect of changing that one reactant on the overall reaction rate. So it's kind of like a study that says, okay, I'm feeding these people hamburgers. Hamburgers are making these people gain weight. Well, what from the hamburgers is making them gain weight? Is it the bun? Are they eating too many carbs? Is it the meat? Is it too much meat? Is it the cheese? Is it from dairy? Well, if you're just feeding them burgers, you're never ever going to be able to determine what exactly is making these people gain weight. You have to isolate one of the variables. So you got to feed either just meat, feed somebody just the bun, or feed somebody just the cheese in order to determine the effect of that variable. So in the same way, you're picking two experiments that you only change a single variable, so then you can determine that variable's effect on the overall reaction rate. And so given experimental data, this is what I usually do in order to determine the overall reaction rate and the reaction rates for each of the reactants. First thing I do, as I said a little bit earlier, was I look for two experiments in which I'm only changing a single reactant concentration. Once I find these two experiments, I compare their reaction rates and I compare the concentration of reactant that is changing. And I write down each of these numbers. So say, for instance, the concentration of the reactant doubled. Well, then I write down 2 and then say that the reaction rate went up by 8 times. Then I write down 8. And now I use pretty simple mathematics. I say that 2 to the n is equal to 8, and I solve for n, and that is my order, which in this case is 3. And essentially what this 2 to the n equal to 8 expression is saying is, by what factor does the reaction rate change if I change the concentration of reactant X? So you're just looking at what happens to the reactant rate if I change the input concentration of a reactant. And so once I do this for one reactant, I'll go ahead and do it for the next reactant and the next reactant until I have all the orders for each of the reactants. And then boom, now you have the rate law. You know now that you have A to the third times B to the second, or B to the first, whatever the order of reactant B is. And then what you can do is you can add up these individual orders for each of the reactants to determine the overall reaction order. So just remember, the overall reaction order is simply the sum of the individual reactant orders. Okay, so that is mathematically how you determine the overall rate law or determine the order of a reaction. What about the other way I was talking about? Well, the other way to determine the rate law for a reaction and determine the reaction order is to get it from the stoichiometry. But this has a huge caveat. You can only do this when the reaction is elementary. And what do I mean by elementary? Well, elementary simply means that the reaction is a single-step reaction, which, if you think about a lot of these biological reactions, they're not really one step. Take, for instance, the reaction that converts glucose to 2 molecules of pyruvate. Is that reaction elementary? Well, if you answered yes, then you are probably not ready for the MCAT, or you're maybe retaking it now. But a single step elementary reaction would be something like a molecule of oxygen and a molecule of oxygen react together to form O2, something like that. Glucose, on the other hand, goes through a bunch of different steps in order to make pyruvate. It goes through all these steps of glycolysis in order to make pyruvate. You release 2 ATP, you require some NADH, or I guess you produce NADH. But anyways, the point I'm trying to make here is that unless you are very specifically told, this reaction that you're given is an elementary reaction, do not use the way I'm about to tell you to determine the rate law for a reaction. Instead, you're going to have to use experimental data that you've been given in order to determine the rate law. So never just skip ahead to this step unless the passage says this reaction is If a reaction is indeed elementary, my dear Watson, then all you have to do is you use the stoichiometric coefficients from that reaction and just plug them in to the reaction order for each reactant. So let me give you an example. Let's say that you're given the equation that 2 O2s react with 1 CO2 to form CO4. And I'm just making that up, but just pretend that that's the case. Well, I know that my rate law is going to be that the rate is equal to some constant K times the concentration of O2 raised to some power times the concentration of CO2 raised to some power. All I got to do, since I know the reaction is elementary, is I go back to the original reaction, and I know that the stoichiometric coefficient for O2 is 2. So I just say K times O2 squared. And then I look at the stoichiometric coefficient for CO2. I see it's a 1, and so I just leave CO2 as it is, right? Anything to the power of 1 is just itself. And in the end, the rate law then becomes that the rate of this reaction is equal to K times the concentration of O2 squared times the concentration of CO2. So again, all I did is I took these stoichiometric coefficients and I plugged each of those into the exponent for each of the reactants. And I've honestly seen the MCAT do this either way. So they might give you experimental data and you have to solve then for the reaction order using the experimental data, or maybe they don't give you experimental data, but somewhere in the passage it says this elementary reaction, blah, 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 and then you'll get asked about the rate law. So the MCAT can ask you it in a few different ways. Just understand that if you're not explicitly told it's an elementary reaction, don't just assume the stoichiometry determines the rate law. That is a huge mistake that students make, is they'll say, okay, I have the stoichiometric coefficients for the reaction. I'm just going to plug these into the rate law. Well, that's bullshit. That's not how that works. And so what you got to do is you got to use experimental data then that you're given, hopefully, to be able to solve for that rate law instead of just taking the easy way out with the coefficients.